Yesterday we added fractions that have the same denominator. Today we're adding fractions that have different denominators. Now remember, when we add and subtract anything, we can use our number line. But if we have fractions, we have to know what the units are down here. The problem is that right now I have fifths and I have fourths. So just like adding apples and oranges, I don't know what to write down here. I can't do anything until these are the same unit. So my goal is to get the same denominator or bottom part of the fraction. Because when I have the same denominator, then I know what my units are, and then I can write that down here and add them up. So there's two ways to do this. You asked for two different ways of doing things, and I'm going to show you both of them. One is that we want to write these as equivalent fractions. So for example, with 3/5, 3/5, an equivalent fraction is the same amount, just written in a different way. So I could write this as 3/5, but if I broke each of those pieces of chocolate into two more pieces, then what we have is we have 1, 2, 3, 4, 5, 6 pieces out of 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 pieces. So instead of writing 3/5, I could write 6/10 if I wanted. They're equivalent, they're equal, they're the same thing, they're the same amount. So anytime I see 3/5, I can write 6/10 and vice versa. The thing is, this isn't helpful yet because 10th and 4th, still not the same thing. So let's write out some more equivalent fractions just to see what we have to work with. Let's say I took each of these fifths, each of these blue pieces. Instead of breaking them into two parts, I could break them into three parts. So that would be 3 times 3 is 9, 5 times 3 is 15. Notice it's just counting the multiples here. So 3, 6, 9, 12, 15, 5, 10, 15, 20, 25. I don't know when to stop, but let's look at this one and see if there's anything useful there yet. So here I've got 1/4. Count by my multiples of 1, 1, 2, 3, 4, 5, 4, 8, 12, 16, 20. Oh, look! Here, 5/20 and 12/20 have the same denominator. So I can rewrite this as 12/20 plus negative 5/20. And then over here, my units are 20ths. And I can just add like normal. 12 positives, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. 5 negatives, 1, 2, 3, 4, 5. And I can count 1, 2, 3, 4, 5, 6, 7 20ths. If you have another way to do that subtraction, that's totally fine. But either way, our goal is to get the same number in the bottom so that we can just add or subtract across. The other way that you could do this, you're going to do the same thing with the number line or with whatever adding you want to do. But the other thing that people do is they look at these numbers. So here's our 3/5 plus negative 1/4. And they say, okay, what number could I multiply this fraction by in the numerator and denominator? What number can I multiply this fraction by in the numerator and denominator to get common denominators? So that you kind of just have to know. If I multiply this by 4, and I multiply this by 4, and I multiply this by 5, and I multiply this by 5, then I would get 12/20 and negative 5/20 again. So this, at this point, is the same as this. So if you want to do it this way instead of this way, that's totally fine. Whatever way makes more sense to you. Now, looking at this one down here, same idea. I've got 1/3. I'm going to write some equivalent fractions to 1/3 until I get something that works. So 1, 2, 3, 4, 2 sixths, 3 ninths, 12ths. These are just the multiples of 3. These are the multiples of 1. And if I look here, I'm going to start with 5 sixths and then start writing my multiples. So let's see, 10 twelfths, so on and so on. Oh, I see a 12th and a 12th here, but actually, even smaller numbers, I see a 6th, 5 sixths here, and 2 sixths there. So I'm going to use negative 2 sixths minus 5 sixths. And remember, that's the same as adding the opposite. So here, sixths, 2 negatives, 5 more negatives, and I've got 7 negatives over 6, so negative 7 sixths. And again, if I group that 1, 2, 3, 4, 5, 6, that's also negative 1 and 1 sixth. Both of those answers are correct. And then in terms of our second way to do it, I can also see that this is negative 1/3 minus 5 sixths. If I multiply numerator and denominator by 2, then I will get negative 2 sixths minus 5 sixths, which is the same as what I had here. So if you want to do it by multiplying numerator and denominator, or if you want to do it by writing equivalent fractions, either way will give you the same answer.